Now let's take a look at the cloud creation workflow with using the Fog VDB. So in here, as always, let's create a geometry node and dive inside. And in here, first we need to create if you type cloud, if I type cloud in here, and here as you can see, we have all of these different types of nodes to create the clouds, to shape the cloud and all of them. And if I also go into the environment, this menu, and in here we have the sub menu, and in here we have the clouds, and here we can create the clouds. We have all of the same nodes, and we can also go into the sky, and in here we also have a node called skybox. So maybe let's create a skybox in here, and let's add this, and now skybox has been added. And now if I press and hold the middle mouse button, and here as you can see, we have an A1 VDB volume. So we have this density volume, it is a fog VDB, and we have its voxel size, and I can see that it is filled with some volume because we have some megabytes in here. So here as you can see, we have this instance location 3.68 megabytes, which means that we do have some value inside of this VDB volume. But right now I cannot see my clouds volume, and that is because we need to zoom out. And let me take a look, and here as you can see, on top we have some clouds. And to actually view all of our geometry, you can right click and click on this home all button. By clicking on this home all, Houdini will zoom out to all of your scene where we have all of our geometry. Okay, so in here I can see this beautiful clouds skyscape. And now let's go into the parameter of the skybox, and at the top we have the voxel size. As you know, voxel size is the resolution, which means if we want to create more high-res version of our clouds, we need to decrease the voxel size. I'm going to just keep this voxel size to 5 for faster feedback. And in here we have the seed, that is the random seed, because we are using all of these noises to create these clouds. So if I were to change different feeds, and here as you can see, we are getting the random variation of all these clouds. I can change this to any seed value, and up at the top in here we have the feather tab, and in here we can define the coverage. And if I were to change this to all the way up to 1, and now we are filling out all of our this bounding box with clouds. I'm going to just lower this value down to default 0.5, and we have the precipitation, and that is, I think, for the precipitation control, that if there is going to be a rain or not. And if I were to increase the precipitation, and here as you can see, our clouds are getting thick, which means they are likely to rain. And let's zero this out, and we also have this anvil, and if I increase the anvil, it will just increase this thickness of our cloud. And if I were to lower this value down, and here as you can see, we have these thick clouds, and if I were to increase the anvil, we will get more thick cloud. We have its height information in here, and we are keeping this bottom as the same. So let's zero out the anvil, and down here let me make this pane a bit bigger, and in here we can change the look. Let's click on this override look option, and remember that is just for the viewport visualization only. It's not going to apply material, it's just for the viewport visualization. Right now we are using the ambient occlusion. We can change this to reverse occlusion, and that will create a more cloud-like visualization. And maybe let's change this to ambient occlusion so that we have this better feedback of these shadows. And you can collapse this menu, and here we have the density scale and also we have the parameter for the shadows. Let me collapse this, and first we have the sky setup, and in here we can define the size, how much we want, how big we want our cloudscape to be. I can lower this value down, I can make this value bigger. These are the basic size, and we have the option for the center to place it wherever we want. And down here we have the sky layer, and first we have the altitude adjusts this y position, and if I were to lower down the altitude, and here as you can see I am effectively adjusting my y position, and you can adjust the altitude, and we have the option for creating more thick clouds. And here as you can see, if I were to increase the thickness, now I am getting these thick clouds, and I'm going to just make these values to default. And to revert these values to default, you can either right click on the parameter, and in here you can change this to revert to default. Click on it, and there we have it, these default values. And you can also make these values default if you press and hold the control key and middle mouse button on the parameter, it will make these values to default. If I right click, and here as you can see, we also have the shortcut revert to default, control plus middle mouse button. And now down here we have the sky field, some other option, all of these noise parameter. And on to the next tab we have the bellowy noise, and in here we can adjust the element size. If we were to decrease the element size, we are creating more of these breakups we are creating more this high frequency noise. And I can increase the element size, and in here I can add some worldly detail. It will break up this noise even further. And here as you can see, now we have a lot more detail, we have a lot more smaller all of these clouds. I'm going to uncheck this, and in here we have the alligator noise, we have the another type of noise. So basically we are just layering down all of these different types of noises to create this cloudscape. And we also have the wispy noise. I can enable this to make my clouds wispier. And here you can see, by enabling the wispy noise, now we are getting sort of these thin clouds. We do not have the thickness. And animation, we can enable the animation and all of these things. And that's how basically you can create the simple skybox. But that is good for creating this environment, this top level, this cloudscape. But now let's see how we can create the hero cloud. The way that we can create our own hero cloud by using a cloud node. So if you type cloud, and here you can see we have all of these nodes for working with clouds, and down here we have this option cloud shape generate. So let's add this. First we need to define the shape of our hero clouds, and for that I'm going to use the cloud shape generator. So let's add this and view this, and cloud shapes generator has been added. And right now I cannot see my cloud shapes. That is because our cloud shape is down here at its scale is very low, and right now we have been zoomed out to a 625 units, so which means we need to zoom in, or I can just press F key on my keyboard to frame this selection, and that way I can very quickly frame my camera onto this scene. And here you can see the cloud shape node will just create these bunch of sphere, and this sphere will define the shape of our hero cloud. So we have this silhouette. So that's how our cloud is going to be look like. I can go into the cloud shape, and in here I can increase the shape offset. By increasing, I can adjusting the shape offset. I'm basically adjusting the random seed, that is the random variation of our clouds. And in here we can adjust the point separation. By increasing the point separation, I'm increasing the scale of our sphere, and I am creating less of these points. And same way, if I were to decrease the point separation, I am adding more sphere, and thus we have the smaller scale size sphere. I'm going to just make the point separation to default. So press and hold the control key and middle mouse button to revert all of these changes to default. And on top we have the initial size. I can change the initial size to make my cloud bigger or smaller. And we have the cloud species. So let's see. So in here I can change this to Humulus. Let's see. And onto the Humulus we have these different types of these flatten out clouds, and I can also change this to Congestus. And now we have these clouds that have this vertical alignment. I can change the shape offset to add the random seed, and I'm going to change this at the 0, and maybe let's change this to the value of default. And into the length I can adjust the length of my cloud, and onto the width I can adjust the width of my cloud. Let me make this a bit into the defaults. And we have the option for the distortion. I can distort my shapes, and we have the option for the flattening the bottom. And here as you can see below why we have these shapes flatten out, I can uncheck this, and now here as you can see we do not have any flattening effect. So maybe let's keep enable this flattening option, and I can adjust my this plane, flattening plane. So let's default this out as well, and in here I can play around with the rotation of my cloud. So maybe let's change this to default as well. And right now here as you can see we have these points. If I were to middle mouse button, and here as you can see we have these 427 points, and it is a sphere type points, which means it is a primitive type sphere. If I were to create a sphere, add a sphere, and here as you can see we have these two types of sphere, polygon and primitive. If I were to add primitive sphere, that is this sphere, and basically this primitive sphere is just a 1 point, and it has a certain radius value. So we can set the radius by using this uniform scale, and Houdini is drawing this point as a sphere. And same thing is happening here. We have these points, and these points are visualized as a sphere, but they are just point. And with that we have some attribute. We have a cloud ID, and we also have the P scale. Now P scale is important. So cloud shape is scattering bunch of points and creating this cloud looking type silhouette with these sphere radius, and it has the P scale value. So now we just need to convert this into fog volume, because right now it is not in a volume, these are just points. To actually convert this, we have a node called VDB from particles node. So VDB from particles will use the points as an input, because we are not working with polygons. These are not polygons, they are just points with the radius value. We need the VDB from particles node. So let's add this and connect this in here, and let me view the result. And here as you can see we have the surface volume, surface type volume. So surface type volume is the default settings for all of these converting VDB nodes. So let's go into the VDB from particles, and let's uncheck this surface VDB but enable the fog VDB. And now we have the volume representation of our cloud, and we can adjust the resolution by decreasing the voxel size. So let's lower this voxel size to a maybe value of 0.05 to create a bit sharper cloud. And here as you can see we are getting this accurate silhouette, and that is because of the P scale value. And the VDB from particle node will use the P scale value to set the scaling of this fog VDB. And if I were to, let's say, remove the P scale attribute, so if I were add an attribute delete node in here, and I'm going to just click and in here check delete non-selected, which means we are removing all of the attributes. And here as you can see we do not have any attributes, but we just have this basic shape. And now if I view the result, and here as you can see we are getting this thick blob, and that is because of the P scale. We do not have P scale, so the VDB from particle node will use this point radius scale to set the scale. So I can adjust the scale by adjusting my this parameter, and here as you can see we are manually setting our this P scale value, and that is why this P scale value is essential. So let me remove this attribute delete node, and here as you can see we are getting this lot smaller scale because now this will act as a multiplier of our original P scale value. So I'm going to just change this to value of 1, which means that we are completely using the values, P scale values that are coming from our this cloud shape node. So let's go into the cloud VDB from particles. Now we have the fog VDB, and now let's add some of these noise disturbance onto our these clouds, because right now it is a very smooth looking cloud shape. So in here let's type cloud node, and in here we can see all of these nodes. So I'm going to just add a cloud noise node. So let's add a cloud noise and click on it and view the result, and here as you can see we have some noise happening in here. I can increase the amplitude. Let's continue increasing the amplitude. I can really break up my cloud shapes, and I have some octaves. I have the element size. This one we have some override look option, which means we can calculate the ambient occlusion to better visualize in our viewport. So let's enable the override look, and now here as you can see I am getting a much better representation of our this look, this viewport visualization. And same way onto the ambient occlusion we can change this to reverse occlusion. That will create this more accurate cloud looking visualization. Let's change this to ambient occlusion, and same thing I can play around with the density and play around with these shadows. I'm going to just keeping them at the default, and same thing onto this below tab we have the noise. I can play around with the amplitude to increase the amplitude of my noise. I can add the lower down the element size to add the smaller scale details, and let's add a overlay detail noise as well. That will further break down our this noise. So maybe let's lower this down amplitude value to a value of 0.1, because I think let's maybe change this to 0.3. So we have a lot of breakups. I think the value of 0.1 is fine. I like these breakups. And let's go into the advection tab, and let's enable the advection. This advection will just further distort our this primary noise. I can increase the amplitude scale. Let's continue increasing this, and I think we need to lower down the element size, and that will effectively just distort our this primary fellow noise. Let me increase the element size and lower down this element scale. So we are getting some breakups in here, and to actually capture more of these details, as you know, we need to increase the resolution. So I'm going to just change this to value of 0.01, and it is taking longer to calculate, but we will get a higher resolution volume, and here as you can see. So for faster feedback I'm going to just increase the voxel size so that we have a bit snappier user interface. Let's go into the cloud noise, and onto the processing tab we can define the number of noises, and we can, if I increase the number of noises to 2, and that means we are creating these multiple layer of these below noises, and I can play around with its parameter. We have the expand scale, and right now all of these options are not very snappy because of the high resolution. And after that we can just keep layering down the noises. I'm going to add another noise. This time let's add a cloud wispy noise. Let's add this and connect this, and here as you can see we are creating this wispy type noise. Let's bring up the parameter. Here I can adjust the amplitude, and same thing we have the element size. I can increase the element size to create high frequency or low frequency noise. I'm going to just create a high frequency noise, And maybe let's lower down the amplitude value, and same thing, advection, that will restore the noise. And onto the velocity, we also have the option to enable the wind. Let's enable the wind, and that will use this direction to add a wind type deformation. So I can increase the wind strength from here. And here you can see right now we are using the wind type in the X direction. And here you can see the noise will affect as if we have the wind and it is blowing out the cloud onto the X direction. And maybe let's increase the amplitude value to 1. And here you can see our cloud has been eaten up by the wind from the x-axis. I can change this to -x by changing this direction to -1. Let's play around with this value to exaggerate the effect. Let's keep this to a value of 1 and go into the wispy noise, and this time I'm going to just lower down the amplitude value. Let's lower this down to maybe a value of 0.5. And after that I can add another cloud noise in here, and this time I'm going to just add a simple cloud noise. So let's add this and connect this in here, and I can adjust the amplitude, and right now it's calculating. Okay, I think it has been calculated. Let's increase the amplitude, and here you can see we are creating this very nice looking cloud, and we are getting some lot of breakups. So you can just keep adding these noises, and you can keep massaging this hero cloud noise to your own liking. And in here you can see we are using this simple cloud shape generator. We also have some other option. For example, if I type cloud, and here you can see we have this cloud shape from polygon node. So let's add this. That will expect a polygonal geometry, so which means I can create a rubber toy by this geometry and connect this in here. And let's plug this, and what that will do, it will just scatter the points. It will pack these spheres. I can go in here, I can play around with the packing density to create more or less of the sphere. Again, as you know, these are just points, which means we need to connect this into VDB from particles node, particles, to convert this into actual volume. And let's view the cloud noise with the cloud noise. And I think we need to adjust the parameters. So first I'm going to just take a look with this cloud bellowy noise. And here we have the cloud shape from this rubber toy, and we also have some other option. Let me type this here because it was cutting off. So into the cloud we also have this one cloud shape from line. So let's add this. What that will do, it will expect a line. I'm going to create a helix node to create a line. So let's view this here. Here you can see we have the helix, this spring type. Let's bring up the parameter, and we can adjust the parameter. I can adjust the height, I can adjust this turns, I can adjust the radius. We have this radius scale value, all of these options. So now I can just connect this in here, and let's view the cloud shape from line. And here you can see it is just scattering these bunch of sphere along with these helix. I'm going to increase the point separation for creating more or less of these points. So now we just need to plug this into VDB from particles node. So I'm going to just plug this in here, and we should start to see the clouds. And here you can see we have these clouds, and they are based on our spiral. So I can adjust its height, and here you can see we have this visual live feedback. So that is the basics of creating the clouds. That is the cloud creation workflow.